Hey everyone, today is video number 2 in our series for wiring a low EMF home. And today we're going to be covering wiring. I'm here with Kevin Fortney with Fortney Electric. Kevin, thanks for joining us.
You're welcome.
So Kevin was a key part in wiring this entire house that we're standing in right now. And today we're going to walk you through step by step the really important pieces of the wiring part of a low EMF home. We're going to walk you through. Kevin's going to show you everything that we went through. So stay tuned and let's get going. During the wiring stage, there's a really important part that's part of this sub panel. Kevin, can you explain to us what we got to make sure of with the neutral and the ground?
Yes. So there's a neutral bonding screw, which is a green screw that typically comes in most panels. You just have to make sure that is not in if it's a sub panel. So that would basically bond your neutral and your ground wire together, which is only bonded at your service where the utility company comes in, and which is where your meter is. So
that's down like that's the service or the main meter where you get power, and then you branch off there through disconnect to your house.
Correct.
Okay, so you want your ground and neutral to connect inside that disconnect.
Yeah.
That point there, but that's the only point.
Only at one point, correct.
Otherwise, we get higher magnetic and electrical fields in the house.
And correct. Yeah, higher magnetic field, and it's not code.
Gotcha. Okay, good. Okay, so that bonding screw has to be removed. It's code to be removed, but you saying it's common that it's not removed?
It's common. It's not removed. Correct.
Common error that's done during the actual wiring phase.
Yes.
Okay, so we got to make sure that, and then the other thing about during the wiring phase is inside of your sub panel. This could be a sub panel like we have behind us here, or it could be a disconnect on the side of the house. This one has a disconnect where because our main meter is down 100 feet away or 160 feet away from the house, we had to have a shut off at the house.
Correct.
So this could happen in either one of these locations, but can you explain to us what happens when you have separation between those individual wires that are coming up into the house from the subfeed?
Yeah, so greater the separation of, we'll just talk about your neutral and your hot wire, is you'll have a greater magnetic field. So you want to try to keep those wires as close as possible until they terminate into your neutral bar and into your breaker. So to minimize the magnetic field. So that's the whole reason about trying to get the PN Siemens panel, is because they have neutral bars that run up both sides, and it's the easiest panel to try to keep everything as close as possible.
So you have your bars on both sides for the neutrals, and then you're keeping the neutral and the hot side by side as long as you can.
Correct.
And then you separate them as close as possible inside of that.
Yes,
panel.
exactly.
Yeah. So the farther the separation you have between the wires, what is that increasing inside why do you want them to keep them close by?
Because the greater the separation, the greater magnetic field.
You get a bigger field coming
Yes.
out. Okay, so that's a important thing of why when we're talking about the location of this panel, get this panel away from anywhere you're going to be sleeping, anything like inhabiting any part of your house, because there's at least around this, when we put our Gauss meter on this, it's at least 36 inches around this thing. You get a field, even with the right panel that we have.
Correct.
So we got there, and the sub feed is a similar situation down there. Like there's really no way, even with this panel, to keep those wires close together.
Right.
So where it's coming out of that rigid conduit, it splits, and that starts creating a field because they're not lined up tight together. The hot neutral,
right,
are not
exactly.
close together. Yeah, so that's really important. Make sure you get the right sub panel. That's really important. And those other tips that Kevin was saying as far as the process. So like Kevin, he's getting ready to show us something else here. It's really important on the wiring, but I want to introduce 2 books to you that are really helpful as far as if you are building a house with the intent of having low EMF. There's a book by Carl Riley called Tracing EMFs in Building, Wiring, and Grounding. And this is a book that we read in reference to throughout the process. And there's also a book here called Prescriptions for a Healthy House. This is the 4th edition that we have here. There's a whole section in here on electrical. It tells you the different the parameters in that, what you're looking for, and recommendations on what to do for the actual wiring in your home. So these are helpful. Make sure you get these and read them. There's no audiobook on this or this one, so you got to read. All right, so now we're going to be looking at 3-way switches and ganging neutrals from different circuits. And this is a really big issue for getting a large magnetic field in your house, eliminating that if you do it right, or creating one if you do it wrong. So Kevin's going to walk you through and show you and explain to you what you need to do, because this box has 2 circuits in it, which you try to avoid, but if you can't, you got to make sure the neutral's done right. And also he's going to show you how to do three-way switches. So he's going to show you that now.
Okay, so neutrals, if they're part of different circuits and they're not breaker tied together, you have to keep them separate. So that's the whole reason this neutral is not tied in with this one. This right here is a three-way switch, and the part of the three-way switch for this is the switch leg side. So this neutral is, we get this neutral from the power side of the three-way switch, which is down at the bottom of the stairs. So, and what we found is if you tie this neutral in with the same circuit neutrals, you have a high EMF. But if you keep this neutral separate and it travels exactly the same path as your travelers and your switch leg, then the EMF is a lot lower. So, but it's okay to have your neutrals all tied together if you have only powers and a neutral that is going to either to a switch leg or with a three-way. But it's just on the switch leg side that it has to be tied through and not tied in with the other neutrals of the same circuit, which is a standard practice.
What happens to the other, say you have other neutrals from that circuit in the same box? Can you gang those neutrals together as long as that one's kept separate?
You can, as long as it's power or an individual switch leg.
Okay, so power individual switch leg. Okay, can you explain to them what if we start at the panel, the sub panel for the branch circuit, what wire are you running to your first box where the first switch is at? What are you running to that point?
That would be a 12-2, but
12-2.
in this house, it's a 12-2 because we have 20 amp circuits. It could be a 14-2 if you're doing a 15 amp circuit. So yeah, we'll say the power down there is a 12-2, and then we have a 12-3, which is for your travelers for a three-way switch. And then from this point is another 12-2 out to your light. The only thing different in this is that our neutrals do not tie together of the same circuit because it creates that higher field.
And the reason that does that is because it gives the power, the hot's bringing the power in, and then the neutrals are going back, or the power is going back to the panel on different paths on the neutrals back there. So if you had, say, this circuit that he has coming here, if it runs on the other side of this room and does a whole loop around here, it's going to create a field because we've separated the hot and the neutral that would typically be side by side inside of just a regular wire right here or cable, and it canceling itself out. It's not canceling itself out anymore. It's creating this huge field in a room. And you can have, like, if you have this wire drawn, you could have four milligauss just inside of a whole room. And it's creating a field that you're living in. So just by reconnecting these wires correctly, it'll completely eliminate the problem. So you have to go through and you have to check that. You'll find a net current on those based on the fact that it's not a balanced load in the cables running. So super important. And then what about the ganging of the neutrals? How can you explain that to us?
The ganging, yeah, of different circuits would be, first off, it's not code if it's not breaker tied. And second off, if you tie two circuits, the neutrals together, say 220 amp circuits on A and B phase, that would be fine if it's breaker tied together. But if it's not, then that's not code. EMF speaking, it would just create a bigger magnetic field, and it just causes more issues in that room for the magnetic field if you're trying to eliminate it.
So similar kind of thing, you got two circuits, you put two neutrals back together. The hot is delivering power, and half of it may be going back or on one circuit, the other neutral on one circuit, and half to the other, or a third on one, or 0.7 on the other. And that's caused by the amount of resistance that's on that, or impedance that's on each circuit. So you get that, again, you're spreading out, you're not getting the cancellation in the loads from the current going side by side, and you create a field within the house. So that's a really simple fix. You just have to find that, you trace out the net currents, and then you go back in there and then get them to where they're not tied together. Make sure circuits are individually, the neutrals in the box, right? That are
Yep.
neutral. And that's all. So that's a big mistake from an EMF standpoint in a home. All right, so we're down here at the main service. So this is where we get our meter. It's a 400 amp service coming in from a utility company. This is a 200 amp disconnect here, another 200 amp over here. So Kevin's got this opened up for us. And can you explain to us, Kevin, what you want to see in regards to your neutral and your ground down here at the panel, the bonding that happens here, and what in relation to what you don't want to happen at the house, and how that affects the magnetic fields in the electric fields at the house?
Gotcha.
Yeah.
So yeah, right here is your grounding screw, which bonds your neutral bar, which is on both sides, and to your ground, which is on this side, which goes to ground rods.
Mhm.
So this is the ground for your whole system. And the only spot your neutral and your ground should be touching is right here at that screw for the entire house. And we pulled the neutral off to test that just to make sure, because since we're working on EMF, we don't want any unbalanced loads, which if the neutral and the ground were touching, that would give us an unbalanced load. And so up there at the disconnect and at your panel, these screws are not there. So it basically isolates your neutrals in each one of your disconnect and your sub panel. So
your neutral's not touching your ground and your sub panel up at the house.
correct.
Okay. And then we're not having, that helps us to eliminate having to two paths back to this panel for
as an unbalanced load.
As an unbalanced load coming back. And then you check the continuity to the whole to make sure we didn't have a neutral to ground connection up there at the house, like in the whole sub panel, by disconnecting this neutral. And then you touch that neutral to your ground here.
This neutral, we isolated it.
Yep.
And then we touched with one prong the ground and the other prong the neutral.
To the neutral.
Correct.
And what did that tell, when we checked that, what did it tell you?
If you didn't get a tone, then it meant that there was nothing was touching the neutral or the ground at any location beyond this point up to the house.
So we were able to check essentially every circuit, every branch circuit in that sub panel to the house that we did not have a neutral to ground connection.
Correct. By
doing that, which saved a lot of time. Like you'd have to go pull off every single one of those branch circuits and check it to see if you had neutral to ground connection, where it would charge actually like anything metallic in the house and actually send something down a gas line and then back down a ground wire of some sort, or even back on another circuit potentially, which would unbalance the load. So that was something that we were able to speed up by Kevin doing that right there, taking that neutral part and then testing that there, the continuity there.
Yep.
So, okay.
Exactly.
So we want to have that connected there, but not in the house.
Correct.
Yeah, the ground. Okay, awesome. Okay, so another important consideration in your wiring phase is making sure that your sub feed that has a ton of amperage going through it. So it's feeding your sub panel in your house. And this one specifically behind me, I have a disconnect on the house. It's coming from the main meter base outside, or the service panel outside. It's coming in here. We got to make sure that we don't get a magnetic field coming off of this and affecting our floor up above or the wall right here. So we got to make sure we do that we can control that and shield that so it doesn't come into the home. So Kevin's going to go over what we decided to do here and why and walk you through it. So can you tell us what we decided on, Kevin?
Yeah, so we decided to do rigid conduit because it will, since it's the highest current flow in the house for wiring, we used rigid to minimize the magnetic field. So it's rigid conduit is a lot thicker than EMT or the MC cable, as you'd see here, because they make feeders that do go inside the MC, but that's a very thin jacket. So we ended up going with rigid, which is a pretty thick metal, and it cuts down on the magnetic field a lot. So to make it a lot safer to go underneath floors or up by your head or whatnot for that magnetic field.
So this is connecting the disconnect up to our sub panel?
Correct.
Okay, and then this steel is about an 1/8 inch thick, so is roughly what this rigid is. And this one got together, we used you can look up above us here, if you can see that has the compression couplers. Is that what you were calling those, Kevin, that you put together on those there?
There, and then threaded also.
And some threaded, so depending on how we could get it in there. But we were also noticing we actually got some higher reads on some of these radiuses here. We were getting off of there where the wires were bending. I think it maybe because that wire was separating inside of that conduit a little bit, and you were getting a little bit of more of a field off of those on the radius. We're going to go into another video here that will show you about the shielding, but you can see a bunch of plate steel up above this. Even with this rigid, this knocked down the sub feed. It was like 10 times less than what MC would have been as far as the milligauss in the floor, but we still wanted to get it lower. And with this plate steel, we were able to get it down to like 0.2 milligauss in the floor. And the other thing too, what is the reason that we ran this all the way at the bottom of this floor truss?
Just to give us more space between the floor where you're going to be standing or whatnot. It gives you an extra 18 inches roughly. So, and space with magnetic field is your friend, really, because the greater the space, the less magnetic field.
Gotcha. So that's running at the bottom of the truss instead of, we could have ran it at the top, but we would have been right in the floor.
Right.
So, all right. Well, thanks for joining us. I hope you're able to learn a lot about how to wire a home that has low electromagnetic fields. And we sure enjoyed sharing it with you. Kevin, I appreciate you being here and working with us on the project.
It's been a pleasure.
So yeah, there was a lot of cool things we were able to accomplish with this home. And Kevin, how can people get a hold of you if they're interested in building a home it's got low EMF?
So we're based out of Meridian, Idaho, and you could reach out, Facebook, Gmail. Gmail would be fortneyelectric@gmail.com, or you can call us 208-697-0284.
Yeah, so if you guys are in need of a good electrician that can help you with doing that low EMF wiring in your house, Kevin's a great resource. Reach out to him. So and if you're interested in building a custom home, or building a healthy home or a healthy ADU, reach out to us here at freemansconstruction.com. We also do whole house remodels as well. If you need help with any of your real estate needs, you can go to a real estate company at freemansrealty.com. So thanks again for watching, and we will look forward to seeing you again in the next videos.